Today our class is on the PCB design class using Eagle software. So there's a few prerequisites that needs to be done before starting this class. First, you need to install the Eagle software by Autodesk, and you need to have some knowledge on the schematics. And then after you install the software, which I will put the link on how to install the software below the video in the description, and then we can start to design the board. So today our objective is to learn how to design PCB from schematics. So the schematics that we are going to use is this electric piano circuit, which coming from the elonix.org. So I've prepared the source file that you need to download. So after that, after you have downloaded the source file in the link in the description below, so what you need to do is you open the Eagle software and then file, press open, and then you can open the schematics that you have downloaded. So the file that we needed is exercise PCB underscore design schematic. So after you have downloaded this file, this would pop out. So for this, we need to complete the schematics to become the electronic piano circuit. So here, what we need to do is I've prepared the switches and the resistors and all the other components to make the learning to facilitate the learning faster. So what you need to do is you need to connect this NE555, the timer 555, and then you need to connect it to the remaining components. So let me show you how. So you need to connect the R7 resistor to the source, and then you need to connect this part to this 4.7K resistor R1, and then this part you need to connect to the 7. Okay, how to connect? You need to use this. This is called net, or it can be also called wire. So you need to connect all this wire by using this component. Alright, so what we're gonna do is that we're gonna use this and then go through here, then connect to the pin number 2, and then we also need to connect this part to this point. Okay, after that we need to connect this. Make sure that the connection is connected properly. Resulting name is N7. Okay, then press OK. So after that, we need to connect the pin 1 to ground because it's the ground for the IC. And then we need to connect this pin number 2 for the buzzer to this ground also. And then pin 1 will be connected to the capacitor. And then the output pin number 3 will connect to the C2 capacitor. And then we have VCC plus and the reset pin. So what we need to do is we need to put this connect, and this also connect to here. So after that, we finish our schematics. Make sure you save first. Your schematics before you proceed to the board designing part. So to put this on a board, to put all these components on the board, it's fairly very easy. So what you need to do is first you need to do is you press schematic boards. It would show here. This symbol would show you generate or switch to board. When you press this, it would prompt this warning because you didn't have any board design yet. So create from schematics and then press yes. So now you can see all the components are on this side. Then you have the board that been given to you. So first thing first, before we putting all our components on the board, you need to know that this board can be changed. You can change all the dimensions or shape as per you wanted. But bear in mind, in this free version of the Eagle, you can only have two-sided board. Two-sided board, which is 2 layers. For more layers, you need to pay for the premium software for the Eagle. And then now we have the component. So what we need to do is, first we need to put the component on the board. So you put here, and then if you press right click, you can put here, and then so as you can see, the yellow line are the connections, and then if you move this here, so you need to move all the components on the board first before you continue on how the connection looks like. So the easiest part is do like this. As now you need to arrange the switches also. First, you need to make sure that you want the piano to be looking to have very, how to say, very consistent connection. So you need to have like S1, S2, S3. You need to make sure this will be correct lah. So S1, S2, S3, S4, and S5. Oh no, our board is not. Seems like our board is not enough to fit the switches, but don't worry, you can always drag this. So you click on the edge of this yellow, the board, and then you just drag to make it a little bit larger, and then you can move this switch number 6 to here. But because this is free software, it might not give you the opportunity to do that, so you move back to here. Instead, you extend this to here. But you can also move the components in group. So as you press this group icon, and then you drag, and then you move it to the right. So, and then after that, you move it here. Okay, so this is the location of the buttons is based on how you going to design it, and if you are going to make it prettier or whatever, that is up to you. So because of everyone have their own taste, we are not expecting you to have a similar design the result. And then you can just put the S2, and then you can pull the R3 here, and then you can pull the R4 here, and then you can pull the R5 here, and then you can pull the R6 here, and so on. So here you just need to make sure that your connection is as well as you want it. As you can see here, all these lines, the lines are at the bottom part. So to make things looking much better, you can press the rotate button. Press here, and then we can change. So you see the yellow line, the redness is rotated. So right now we are rotating all the components to make it look prettier. Okay. So then we can move the NE. Now we have the rest of the NE. So we press undo to make sure that the NE are properly situated. So right now I'm going to arrange the NE and the R7. So I would put NE here. Okay, so press move here, and then we can move the NE555. After that, we move the capacitor here, and then because we see that put it here, and then this capacitor also we can move it towards the bottom part of the circuit. So right now what I'm trying to do is I'm trying to put the capacitor at the part below here. So what I want to do is I'm going to press group, and I'm going to move this group to the right area. Okay. And then after that we put here, and then now if, we can just put here, it's fine. And then we can bring this part, this component, and then we put it, maybe if you want to put it here we can also put here, but I will put this resistor here. So right now you see we have all these extra spaces. What you want to do is we want the design to be a little bit compact, so we select this item and then press move, and then we can move all the components. Maybe we can move all the components, maybe we can move it here to make it more compact, and then we press the edge over here and then we pull it down. Okay, so it's as simple, as easy as that for the first part. This is 1K here. Okay, we already moved all the components. Now our next step, we are going to perform the connection. So first you need to understand these few items. First, this root air wire on the left side, and then you can see on the after that on my cursor here, this is it looks like wire but it have X, which means this is used to delete the wire. So for example, if I press this, right, you can see this is the top layer part. Okay. So what you want to do is you want to pull this and to this. You can see the wire is connected from the component the R7 to the V plus of timer 555. So what happened here is that we can see the connection, but this connection also you can change the width or whatever according to what you want. So for example, if you want a thicker width, you can press until 12, and then press again using the root air wire, and then it become much thicker. So for this part, I might prefer using 16 because it's a simpler circuit and we have huge boundaries that we can put. So fret knot, this going to be tedious, right? You can see like there's a lot of work that needs to be done here. But actually there is another way also. You can use the this button here. It's called auto router. So what auto router do is that if you press this, it would automatically route all these so-called redness, the yellow lines, to its own path. But before we do that, one thing we need to do is that it's a good practice that we do this. So basically we are going to make all the ground on this side of the board to be we want to make all this plane to be ground. So what we do is that we press polygon, then we press on the top part, and then we press here, go to the corner of your board, and then to this corner, then connect to this corner, go to the next corner, and then go to this corner, and then the signal name that you want basically to make this shape is ground. So I put it ground. Okay. So it will become like this. And then we go to the bottom part also. We want to draw another polygon on the bottom. So we press this. You can see the blue lines means it's on the bottom part of the board. So right now we draw a second ground polygon. Alright. Okay. And then we go to the top. So right now we cannot see what is the impact of this ground, right? You can see here ground is still floating, and then ground here is still floating too. So what I want to do is I want to press the button redness. So the redness would give you an update on how the connection looks like after each to how the connection looks like after you move all the components. So you press redness, it become like this. Means that all this red is ground except for this part, which is you can see the disconnection in between line number signal number N9 and the ground. Okay, so instead of using a normal routing, so right now I already teach you how to use the polygon, how to use the normal routing, and then the next step that we want to go is that we want to put the we want to use the auto routing. So we press the auto router, and then you can see the top, bottom. This one is usually we set as auto. Maximum running of threads. This is based on your PC lah. So right now my PC can go up to 16 threads. So I'm using the 16 threads. So effort, it's up to you. You want to use low, medium or high. So you can choose whatever you want. And then after that, usually I would put high, and then I will press continue, and then I would press start. And then you can see there is a lot of like optimize for, optimize 12, and the connections, so on and so on, right? So what you want to do is you can choose which one is the one that have vias. So vias or non-vias. Okay. So vias mean there is an extra connection here. They will drill a hole, and it would connect the hole on the top and bottom layer of this board. So the best after we are doing all this, the one that we want to do is we want to pick the optimized 100%, which means all the signals are being connected and with the less vias possible. That is the best one that we can choose. And then we press end job, and then you have your completed board. You can see here your board is the connection of your board, the top part, and then we go to the bottom part. This is your board connection. So the board designing is very easy, and then it's quite simple with the auto routing part. So you can inspect your top and then your bottom layer. Okay, now after we have done with this part, if you want to see how your board reflect in the real world, you can press the manufacturing, and then you can see your board on the preview, top side, and then the bottom side. So this, if you send to the company that are going to fabricate your PCB, this is what you are expecting for your board. And then the bottom side, and then this you can expect this result from the company. Okay, after you have received all the components, and then you need to solder it. But before you send to company, usually company would want the cam data, so or Gerber file. So where you can get the Gerber file is you can press this button, which is a generate cam data. Your design has changed and must be saved to generate cam data. Save your design now. Yes. And then Eagle will create a zip archive containing the following manufacturing files, and then cam output, and then all this, then press OK, and then you have your zip file. Okay. So when you are submitting your Gerber file to if you want if you want to send this, if you want the company to fabricate this, you need to send this Gerber file to them. This for example, this zip file, the one that we have just saved, which is usually have the assembly, which have the exercise PCB design, which lists all your components, and then you are going to have another file, drill files, which is needed for them to which hole that they need to drill in the PCB, and then the Gerber files, which is your masking, solder mask, solder paste, the copper layer for your PCB. I think that's it for the PCB design class for now. And if there's any question, please ask. Thank you.